Okay, at last, we're getting to third normal form. Just to recap how we got here, in the last form we were in, second normal form, we had a student major table and we had a courses taken table. This was better than what we'd had before, because in the student major table we stored facts like the name and the date enrolled only one time, but major doesn't vary by the student. Major is something separate from student. So we should not be storing the name of the major in this table because of the possibility for inconsistency like these two records right here. Ditto with courses taken. We record the courses that the student took by storing the name of the course in here, but the fact of the way you spell college composition is not a function of the course a student took, it's just a function of the course. So by storing the course name more than one time in this table, we open the door to inconsistencies, and my experience has been anytime a database is in less than third normal form, there are inconsistencies in the data. It just happens. So what are we going to do? Well, when we were in second normal form like this, well, just to refresh, back up one notch, when we were in first normal form, we had one table. To move to second normal form, we took the contents of this table and broke it in two. Each of these tables have fewer columns than the table before it. So what happens when you do normalization is you move from a situation of few tables with many columns to many tables with few columns. So to move from second normal form that we are here, we're going to pull major out from this table, and we're also going to pull course out from this table over here, and we're going to wind up with a four-table database that looks like this. We'll have a student and a foreign key for the student's major pointing over to the major table where we'll store the name, one and only one time for the major. Over here we'll have a course table with course ID as its primary key and the name of the course as a piece of data in the table. We'll store the name of a course only once. And every time a student registers for a course, we'll create a record in the registration table, and there we'll store a foreign key to the student and a foreign key to the course, and then we'll store the student's grade. So let's go look at what these tables, the contents of these tables look like. We have moved from a case of one table with many columns to many tables with few columns. So let's see what the data looks like. Well, here's our student table. We've still got, like we did in second normal form, just one place where we store the name of the student, Jim Morrison or Bob Biggs, and one place where we store the date enrolled. So none of that data can become inconsistent. Now we do need to remember what major a student takes. So we have a major ID column here where we set up a foreign key that points to the major, the record in the major table where the student, for the student's major. So this person, Jim Morrison, has major ID number 1. If we look at the major table, that's information technology. This student here, Debbie Dutton, is majoring in major number 2. That's veterinary technology. So now we're storing the name of the major in only one place in the system, and because of that, there's no chance for inconsistency. No matter how many students major in information technology, we'll point them all to this one record, and that way they won't have any kind of different misspellings like we had over here, where information technology was spelled one way in one student and another way in another student. So we've replaced the name of the major with a foreign key to a table that contains nothing but major names. And now we store it one fact, and if we want to change this to information tech later or something like that, then we can change this one row in this one table, and all students pointing at major 1 will get the new spelling. Now, let's go look at the other side of the equation over here where we had the course table. We extracted that from and created a table all of its own. So course looks like this. Now it's just the ID of the course and its name. Again, the name of a course is now stored only one place in the system, and if we decide to change this to Introduction to Programming in Python or something like that, then we can change it in one spot and every registration changes to it. Let's take a look at the registration table. That's this one over here. That contains a foreign key to student, a foreign key to course, and the grade the student received in that course. So let's go look at that table. Here it is. Look at this thing. It's just a bunch of IDs. Student ID, 1, course ID 5, the student received a B. Well, what does that mean? Student number 1 is Jim Morrison. Course ID 5 is 1010 College Composition. So now we know that Jim Morrison got a B in College Composition. And again, we can go right down and tell what's going on. What course each student took, and what grade they got. But we can't tell just by looking at this which student that is or which course it is, because all we're storing here are foreign keys. Just as a sort of an oh by the way, this register table here supports a many-to-many between student and course. Let me back up and give you a little more information. The relationship between student major is one-to-many. A major can have many students. A student has only one major. Okay, that's a one-to-many. But the relationship between student and course is a many-to-many. A student may register for many courses. A course may have many students. To satisfy this many-to-many, we put this register table in the middle, where we use foreign keys to identify the records on the outside, the course and the student, and we store the grade that the person received in that course. Grade should go in this table because grade is determined by the student and the course. So now in this design, where we're in third normal form, there is no information stored in more than one place. The name of the major is stored in one place. The name of the course is stored in one place. No chance for duplication or inconsistencies. The name of the student and the date they enrolled is stored in one place here too. So now we have a design that is good enough to go into production on any database, because no matter what people do over a period of time, no inconsistencies will ever creep into the data. That's very important and is essential in making a good database that users will use over the long run and will trust the information, because what they put in on Tuesday will still be there next Wednesday or something like that. And they begin to trust and rely on systems like this. The effect of normalization was to create many small tables. And as a matter of fact, not only do they have few columns, most of these tables have few rows as well. There are only 2 rows in it. So we went from a situation back in first normal form with the, student info table. Let's go take a look at that, where we had many rows and many columns, to a situation now where we have few rows and few columns in all our table. One of the problems with third normal form, and it's not really a problem, we can overcome it very easily, is now information about a single student is scattered around in 4 different tables. Before, when we were in first normal form, the information about a student was all kept in one table. That seems convenient, but it doesn't outweigh the fact that it opens the door to inconsistencies. And the fact is, if the data in a database is inconsistent, it doesn't really matter what the design is like elsewhere. It's a problem. So I think there's going to be one more video where I talk about how to knit together this information that is scattered around in different tables and make it look as if it was in one table.